In this episode, Solving Logarithmic Equations, episode 3, coming up back into action. Hey guys, today I will show you how to solve logarithmic equations. And by the way, this is the third episode in this series, and for the past two I would link them down below, and also I have separate videos on basic log equation, weird log equation, and I have a bunch of different videos on log equations, and I'll just link them in the description box. Now, say you have been given something like this. Well, again, as a good rule of thumb, if you are given a multiple logs added or subtracted, try to combine them into one. Try to squeeze them, condense them by using rules of logarithms, such as power rule. If you've been given a constant, a number being multiplied out front of your log, you could always bring it up as a power. I have example for this in the second episode, and you could check it out. Quotient and product rules also might come in handy. Now, since on the left side you have two logs being subtracted with the same base, and that's important, so this is my disclaimer, provided that all your logs have the same base. If it's different base, it's completely another story. Now, since we've been given two logs to the same base to being subtracted, we could combine them into one, applying a quotient rule. So I'm going to rewrite it as a one log, keeping the same base, which is 2, and I'm going to write my new argument. So basically it's a fraction, and the argument of the first log goes on top of this fraction, and the argument, which is x minus 2, the argument of the second log, goes as a bottom in that fraction. Now, equals. Well, we could look at the right side, and since our aim to have two logs on the both sides with the same base, having this, we could simply ignore, we could simply leave these logs behind and set the arguments equal. But we have these three kind of hanging around, kind of sticking out, and that three, this number, this constant, makes it's kind of difficult, impossible for now. But we can turn these three into log, basically, and we could combine these two logs, if 3 is written as a log, into one. Now the question is how to make these 3 into log, how to turn these 3 into log. And there is a trick, there is a kind of a ninja trick, and I'm going to show you how to do this. I'm going to do it right off. I'm going to do it off to the side, okay, right off to the side. So sometimes you said something and you still don't realize what did you say. Okay, so, and anytime when you have a constant, when you have a number, you could think of this 3 as a 3 being multiplied by 1. And since this one can be thought of log to the base 2 of 2, since anytime when you have the same base and the same argument, this log automatically is 1. And why I chose 2? Because I have 2 and I want this new log to be with the base 2, not to the other base. Again, this log to the base 2 of 2, that gives me back 1. So 3 times 1 is 3. And now what I can do, I can just bring this 3 as a power for 2 by using a power rule for logs. So and it simply becomes just log base 2 of 2 cubed, which is basically 8. So that simplifies, that reduces to 8. So these 3 basically is going to be replaced with log to the base 2 of 8. So this one, it's the same thing as log to the base 2 of 8. So again, any number, any constant can be turned into log by just using that fact that any number could be thought as a 3 is as that number being multiplied by 1, and 1 could be thought as a log to that base that you are given of the same number, same argument. Anyway, I'm going to replace this 3 with the log 2 of 8, or if you could figure out these things in your head, more power to you and go ahead. But sometimes it's not that obvious, and sometimes it might be a little bit tricky. So this is kind of trick, a ninja trick that I always use, and if it comes to this, you could also use it. Now I'm going to replace this 3 with the log to the base 2 of 8, and still we have this log to the base of 2 of 1 plus x. Yeah, it's gonna be a little bit mess. Right, now on the right side I can do the same thing what I did before. So I can squeeze, I can combine these 2 logs into 1 by using a quotient rule. Go ahead. I'm going to rewrite the left side as is, so it remains the same for now. X minus 2. And I would have 1 log. Since we have the same base, 8 goes on top, and 1 plus x, basically the argument, whatever you have inside of the second log, goes as a denominator of this new argument, if you wish. Now that's my favorite part, since we could easily get rid of logs. As soon as we reach that point where you have 2 logs on the both sides of your equation to the same base, we could simply ignore them, leave them behind, and we could come up with a equality of insides. So set them equal each other, so, and it becomes simply just this kind of rational equation in x, and no logs at all, and you have a rational equation, or algebraic equation if you will, and you solve it normally. So I would just move this term to the left side, more algebra basically engaged and involved, but it is what it is, and just solve it normally. So you bring it to the left side by subtracting, and at this point you need to get the common denominator, so it's going to be just the product of these 2 denominators, so it's going to be just x minus 2 times 1 plus x, 1 plus x, not x, okay, x, and your top becomes, so 8 minus 2x. You subtract, this 8 gets multiplied by x minus 2. I'm running out of space. Now at this point I'm going to drop off the denominator, assuming that my x is not equal to, so x cannot be equal to, since that would make your denominator equal to and your fraction becomes undefined. And also x cannot be equal -1. So this is my restrictions, this is my conditions, this is basically values that have to be excluded, have to be thrown out. So your x cannot be equal these two values. So keep going, and I'm going to drop off the denominator, and I'm going to distribute and FOIL it out. These parentheses, I'm going to get rid of them, so it becomes just 8 plus 8x minus 2x minus 2x squared. And I'm going to open up parentheses over here, so minus 8x plus 16, and that equals 0. And again, you need to combine like terms. So negative 2x squared, I'm going to rewrite it as a first term, since it holds the highest power, the second power. So what else? 8x and negative 8x, they cancel out beautifully. And what's left over? Minus 2x, and this constant 8 plus 16, that gives me 24. Since all the coefficients are even numbers, you could reduce your entire equation by dividing by 2 all terms, including the right side. By the right side is zeros, so it becomes same. Anyway, and I'm going to switch the sign. I'm going to basically divide it by -2, because I want my first leading coefficient being positive, not negative. So it becomes just x squared overall plus, I'm going to switch the sign, x minus 12. That equals 0. And this is standard quadratic equation with leading coefficient 1. And again, I have tons videos on how to solve quadratics with different methods and different techniques and fast tricks. You could check it out, but the good rule of thumb, you are looking for two numbers, their product gets to -12 and their sum is 1, they add up to 1, and it's gonna be 4 and -3, these two numbers. So 4 and -3, since 4 times -3 gives you -12, and 4 plus -3 gives you this +1, so it works. Now for the roots, I'm going to switch the signs for the roots for this quadratic. So your first x sub 1 becomes -4, and we end up getting x second just 3. Now again, at this point, actually you have to check your solutions by plugging it back into original log equation and check to see if it works, since sometimes extraneous bad solutions, extra roots might come up, might show up when you do algebra after removing and leaving logs behind. Let me do it quickly. So for x equals -4, we would have log to the base 2 So I'm going to plug it in into x. So it becomes 8 minus, so 2 negative 4 minus log 2, so minus 4 minus 2 equals, well, you could notice that the second log, look at this, minus 4 and minus 2, that gives you instantly negative 6. And at this point I would stop. For me it's kind of a red flag that indicates that this log does not exist. It's undefined. It's nonsense. Since log always defined for the positive value of your argument. So since this one, because you have negative number as an argument, so this one is undefined. Since you would simply get is just log to the base 2 of negative 6. So log of the negative number is undefined. So that simply means that this is an extraneous extra solution that has to be thrown out, rejected. So it's not actual solution, it's not actual root. So I'm going to just cross and delete it. Let's check the second one and see if it works. So you would have x3 and you plug it in for x. So 2 times 3 gives you 6. 3 minus 2 gives you 1. And on the right side, I will put question mark since we're checking and we're not sure. And it's going to be 3 plus 1, 1 plus 3, 4. Well, you could simply evaluate this even without calculator, I believe. So this is 1. So 8 minus 6 gives you 2, and this entire log becomes just 1. This log is 0. So 1 take away 0 is still 1. Let's have a look at the right side. So 3, and this log is just 2, because 2 raised to the second power gives you back 4. So this log 2, and 3 minus 2 gives you 1. 1 equals 1, which is absolutely true, undeniably true. And all that means that x equals 3, that's your actual root, that's your actual solution for that log equation. So it works. Alright, so I hope it was helpful. Thanks for watching and train your brain. I know everyone hates math, but if you like my video, please hit like, share with your friends, leave the comment down below, and be sure to subscribe so you will not miss out my new videos.